Hello, so this is David Ventress, and I'm going to show you what's going on, or at least how it starts with the methods of adding vectors experiment that you're going to do in online lab. I'm not going to take up a lot of your time in this video. I'm just going to show you the experimental part that your data is based on. So we have these scales like this. This is a spring scale, okay? So notice it says newtons here. That's a unit of force that is measured. If you haven't gotten into forces a whole lot in your classwork, don't worry too much about that. It's really more going to be about the vectors than the forces. But anyway, this can measure force, okay? So I can pull on it, okay? I can pull on it and say, let's say I can pull it yay far and it's telling me right now 10 newtons, okay? So I'm pulling on it right now with a force of 10 newtons, all right? So it can measure force, whatever's being applied to it. Now there are three of them attached together like this, okay? So with this ring in the middle. And so normally in Physics 121, when it's a normal in-person face-to-face lab, so the students would have one of these, and then he or she will take it and put it on that round plate and stretch it on the edges, attach it on the edges and stretch it out like this. This might be a little awkward, but I'll do it right in front of you. So like, okay. Okay, so I just attached them like this. So all three forces are on this metal plate pulling against each other. So each of those three forces is something other than zero. There are forces there. But we know that all three of them added together will total up to zero, and we know that because the center point that they're all acting on, it's not moving, it's not going anywhere, right? Okay, now moving a little bit because I shake it with my hands, but with respect to the plate anyway, it's not moving. So all three forces add it to zero, and looks like somebody put a little graffiti there, but that doesn't matter. Okay, so we got all three forces like that, and then what the student in lab would normally do is take a sheet of paper and slide it underneath, okay, like this maybe, okay. So then the student could take this sheet of paper and take a pencil. I might maybe orient it a little straighter. Take a pencil and make a drawing with it of those three forces. So you could just draw around it and do some manipulating with your pencil and so on. And I'm not going to try to do that right in front of you, but what you would end up with is a diagram that would look something like this, okay? So you see all three forces. This represents the forces that are on the plate you were just looking at. So don't know how well you can see it, but anyway, like say there's force A and force B down there, force C over on the left. So all three of them pulling against each other. This represents them. We know what the values of the forces are because we read them off the spring scale. Then you can take a protractor and measure angles in between, okay, like that. So I could get the angle between, say, force A and force B if I hold the protractor something like this and, well, get it right, so, and actually measure, all right? So that's what you're going to be doing a lot of. If you like to draw, you'll probably like this experiment. There are 2 or 3 different drawings you have to make. And so that's the experimental part that it's based on. The rest of it is all just book work, really, just stuff you can do on paper that's mainly calculation, really, and some drawing. So that's about it. So I'll leave you to get on it. Alrighty.